go, here we 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 go.
And welcome back to another episode of Containers from the Couch. It's good to see you all. If you're a new viewer or a new participant, thank you very much for joining. If you've been here before, please say hi. If you haven't been here before, also say hi. Let us know where you're from, where you're joining us from today. Today, we're going to be talking about Fargate and cost. And I'm very happy to have our two guests here today, Wenyen and Olly. Wenyen, could you please introduce yourself? I'm sure you'll do a lot better than I will.
So thank you, Maish, and thank you, Olly, for the opportunities. So I'm a product manager from AWS Compute Optimizer team. So last year, we introduced support for AWS ECS services on Fargate. And this will be our today's topic. We will talk about how to leverage this tool to help you realize the optimization on performance and cost for your Fargate services.
Olly, please. You've been here before, but let's go for it again.
Yeah, absolutely. So hey, everybody. My name is Olly Pomeroy. I'm a developer advocate here at AWS. I sit inside of the Fargate service team. So I work on Fargate, container runtimes, containerd, all of the wonderful data plane stuff behind our container services.
And my name is Maish Lokasing. I'm a developer advocate on the ECS service team, one of many amazing people on our team as well. So, Olly, let's dive straight in. We don't want to take time chatting about the briefs, but there is one thing I do want to notice. If you haven't subscribed yet to our Twitch channel, we are really, really close to hitting 100,000 subscribers. So if you haven't, please do so. We would really, really appreciate it. It'll be a very nice milestone for us as well. And that said, Olly, please take it away.
Yeah, absolutely. So as Wenyen mentioned, the topic we want to talk about today is all about cost optimization, and the way that this we'll focus on today is sizing containers, sizing container workloads, that then relates to sizing Fargate tasks and really cost optimizing your AWS environment. Containers are super hard thing to size. You have a lot of options, you have a lot of customizations, but at the end of the day, you have two real parameters. You have the CPUs, or the amount of cores or the amount of CPU shares you want to give to a container, and you have memory, the amount of gigabytes or megabytes of memory you want to give to a container. And using those two parameters, everything kicks off. The schedulers happen, maybe compute is provisioned for you. Like those two things are the input values, and then the output values is compute and its cost. And really deciding what input values to choose is the hard part. And hopefully we'll help you today with it.
Cool. But I want to ask you a question already. You said it's really, really hard to do. Why? I remember from my old days of right-sizing virtual machines. Why is it any different? I mean, what is so special about containers that you said it's really, really difficult to do?
Yeah, it's a good question, really. And I think one of the main challenges we have is people understanding their workload and understanding what characteristics their workload will have in production, with traffic hitting it, with, I guess, a real environment. And a lot of people, I understandably so, are super cautious. They when they come to trying to size containers, they err on the side of caution, and they often oversize things. And that's okay. It makes sense. You know, you don't want to lose your job for undersizing a container. But the knock-on effect is you have lots and lots of spare capacity in an environment. You have lots of virtual machines or EC2 instances or Fargate tasks that are mostly idle, that people are paying for and not using. And it's this trade-off that we want to look at is we want to right-size workloads, but at the same time, we want to give people reassurance that the resources that we've allocated to them will support them.
Okay, cool.
Yeah, and I think one of the reasons why this is important more related on the Fargate side is because on the Fargate side, for people who didn't know, Fargate actually sizes the underlying compute of what you put in. So those input parameters that I talked about before, the idea of CPU and memory, they correspond quite nicely to the compute that you get given. And I'm just sharing a diagram, hopefully, that you guys can see.
At the moment, we're only seeing your screen with everybody else on it. So,
okay, 1 second. Let me try again. Any better?
Nope, still see the same screen.
Fine. All right, I'll give up with that. But the idea here, is you using a Datadog page?
No, at the moment we only see the same web browser screen.
All right, I give up with that. So
okay.
I'll come back to it in a second. But the main gist is on Fargate, you give us CPU and memory, and what we do on the back end is we right size a virtual machine to run that task. Whatever the input parameters are, whatever the CPU and memory are, is what we size for, and it's what you get billed for, which is slightly different than an EC2 model. So if you're using EC2 with ECS or you're using EC2 with EKS, you put in CPU and memory sizes of a container, and then the scheduler will put that on to an existing virtual machine of a probably bigger size, and it will bin pack multiple containers, multiple tasks onto that same EC2. Whereas with that Fargate side, we are giving you just the capacity you ask for, and you're paying what you ask for. And so if you ask for more resources than you use, you're straight up directly related paying for more resources than you need. And that's why it's more evident on the Fargate side, and I think it's one of the reasons why the Compute Optimizer announcement is awesome.
Okay. So you mentioned a Compute Optimizer. Firstly, for those who are not really aware what Compute Optimizer is it a service? Is it a tool? Is it a document? What is Compute Optimizer?
That's a great question. Over to Wenyen.
Yeah. Thank you for handing it over. So Compute Optimizer is a new AWS service. It's a native AWS service we introduced in 2019. So our aim is basically to provide a native tool within AWS environment and for free to let the customers optimize their AWS resource types. So far, we have supported 5 different resource types, including EC2, Autoscaling Group, EBS, Lambda, and last year we introduced ECS services on Fargate. So speaking to this point, you may have questions about like what's the differences between AWS Compute Optimizer and S3 lenses, and also Cost Explorer's right sizing recommendation. So I would say different services actually have different purpose. So S3 lenses definitely support something else that we don't support. It support moving your S3 to a more less frequent use S3 to a more less frequent and lower cost option. And also Cost Explorer right sizing recommendation is supporting and prioritizing optimizations over everything. It's actually a subset of the recommendation from Compute Optimizer, but Compute Optimizer not only consider your cost, but also your performance. And we slightly prefer to help you build up a resource, right size your resource, so you can run your workload more smoothly. The performance is more important than the cost. Yeah.
There was a question which came in from the chat from Vitaly Greenberg. He asked, why are apps or application teams over provisioning their resources originally? Is it because of, as you said, people are sometimes overcautious, but don't we have enough tools today to actually give the customer, this is what you actually need in order to do that before they start provisioning resources and start paying for them?
Yeah.
Thank you very much, Vitaly, for your question.
It's a great question. I think when it's funny. When I talk to different Fargate customers, I hear different things. Some customers are in their part of the development cycle doing proper load testing on their web application, getting an idea of how the application handles, if it's a microservice or an API or web, how it handles traffic, and they do a lot of stress testing to understand like how many requests it can handle, how many users it can handle at different sizes. And I would describe those as great customers, but I would also describe them as unique customers. There's not too many in that camp, which is slightly frustrating, but it happens. And so customers that don't put that into their development cycles, or don't put it into some of their testing cycles, just I don't want to say the word wing. It's not the right phrase. I like to think it's more scientific than that, but it's not as accurate as size as they'd like. But also at the same time, though, for those that are doing, I would say, a lot of simulating load and identifying characteristics of their workload, the other thing they have to bear in mind is the infrastructure that they're testing on and the environment they're testing on may not be the same as their production environment. They may have different types of compute in production. They may be developing locally on machines and simulating workload and doing stress testing in a different environment to their production environment. And so that also puts in an unknown factor, and it leads to people just putting in a bit of extra capacity that then on the back end is a bit more extra compute and a bit more cost.
Okay. Sounds like good. As you said, I've been with a lot of customers and spoken to them. As you say, a lot of them are on different parts of their journey. Usually everybody says, okay, we'll deploy it, see how it performs, and right size afterwards, which of course this whole thing of cost optimization is going to help us a lot with. And with that, I'm going to pass it over to you, Olly, to continue with the thing with the rest of the... Where does this take us? So, okay, we cost optimization with the AWS Fargate. What is this? Why is this new? Didn't we have this before? Or didn't we have the option to cost optimize on AWS before?
Yes. So I think I can put some inputs here. So basically, there is no intrinsic services within the AWS to help customer determine what's the right CPU and what's the right memory sizes. Fargate, I think it's introduced in 2017, so it's like a fairly new service, and we haven't have this kind of like native support. We realized that there are some like third-party tool that have Kubernetes support. For example, like Turbonomics, they do provide right sizing for their like pods. So that's why we think we want to, being customer obsessed as AWS, we always care about our customers. We want to have an intrinsic native grown tool so customer can know how to use the Fargate to achieve what they actually want. Because the original intention for customer to move their workload to Fargate is because it can scale. It's a serverless container system. It can scale much more easily, and customer also want to be more cost conscious, because Fargate actually help customer do a lot of things. And with all of those, a lot of things, auto scalings and others kind of supports, it does come with a premium cost. And we want our customer to find the best resources that can run their workload in the more cost-effective ways. So that's why AWS Compute Optimizer, we have received so many customers' voices. The large customers, small customer, they are talking about their excitement about the Fargate, but they don't to right size their Fargate's task. And some customers even tell us that they maintain a group to just monitor and then make the changes all the time. So we see the pain point, and we want to come in and help those customers to release some of those resources that's being locked into monitorings, locked into manually optimizing, so they can use those resources, use those engineerings to focus on their core feature development. And that can help drive their business all within Amazon, all within AWS.
Yeah, I kind of want to jump in on that because I agree. Like one of the questions or comparisons we get, like so people run their workloads and they're using monitoring tools to, I guess, assess CPU, memory, maybe network traffic, maybe disk traffic on their workloads, and so one of the questions will be, well, how can we use existing tools to size workloads? And as Wenyen mentioned there, it then becomes a manual task, something somebody will have to do to go to those dashboards, see what they have, and they're not able to kind of simulate the side effects. And what I mean by that is, like, if they make a change and move from one task size down to a second task size, like, is that one hop enough, or should they be doing something more drastic? And that idea of simulating what would happen is how Compute Optimizer is slightly different to some of the existing monitoring approaches people have today.
Yeah. So I actually can share like how Compute Optimizer works, and then we can definitely look into some example what we have created, and then share about how to use our systems to help you achieve your optimization goal.
Cool. So let's dive straight into that and have a look.
Okay, sure. So everybody can see my screen, right?
Yep.
So basically, Compute Optimize, this is how our engine normally works. So we have like 4 different stages. So first of all, we take in some data. And the second thing is to use those data, the utilization data, to generate suitable candidate. In ECS on Fargate case, is a suitable CPU and memory combinations, because some of the CPU, they only have a range of a memory to choose from with a certain increment. So we want to make sure the pair is, the most cost effective, but also can achieve all the performance requirement. So we basically do all the rankings, all the secret recipes will be going in the stage 2 to churn out the final recommendation, a couple of options. And we will have some guardrails to make sure that we double check and make sure there's no spikes in your utilizations. And we did take care of those, to make sure your container not running and then draining because of the self-protection mechanism. Then we move on, we eliminate those candidates, then we move on to the enrichment engine, which we will provide like saving calculations, saving opportunities, and all the extra informations in your recommendations. And we basically eliminate all those. We will rank all the options and only surface the top recommendation that has the best, most cost-effective combinations for the ECS recommendations on Fargate. And here is a little bit more details about the data processing. So the good thing on using AWS Compute Optimizer is that you don't need to pay for like third-party monitoring tools. You only need, what you have to do is just to enable Compute Optimizer, and it's totally for free. It's just one click away, and it's basically seamlessly combined with the AWS organization. So when you are enabling Compute Optimizer and you check, allow all the accounts within this organization to be included in AWS Compute Optimizer, then all the new accounts you created will be automatically enrolled in Compute Optimizer. And we will generate recommendations when you enroll in Compute Optimizer. And the good thing about the ECS service on Fargate is that once you enable Compute Optimizer, you don't have to install even extra CloudWatch agent. We just take in your default utilization data, your memory and CPU utilization data for free. And we will provide you recommendation after 24 hours. So the minimum requirement for the recommendation to be generated is that we have a 24 hours length of utilization data. Because if it's too short, then we cannot tell you, okay, you probably have to right size to this kind of CPU and this kind of memory, because you only have like 1 hour and it's all on the peak. So you have to upgrade your sizes. That doesn't make sense. We want to observe enough patterns so we can make an educated recommendation result to you. And we also, in order to prevent that you will have like a future performance issue, we also add a buffer, basically like a safety margin to prevent if you have like an increased workload. So for a customer who is running like web application or use Fargate for like a backend API, sometimes the traffics will increase, and we will add a 30% of the buffer for the memories and 5% of the buffer for the CPU before we processing and send the data into the candidate generator. And that will help you to have at least a certain type of the margins to deal with a certain outsurge. And you probably will have a question why these kind of percentage is here. It's because we look into our previous data, we found that 30% is the most customers would normally have this kind of spikes within the memories. And if the memories hits its limit, it's unlike CPU, it will normally have a more potent effect on your performance compared to CPU. And that's why we have a smaller buffer ratios in the CPU and larger buffer ratios on the memory side. And yeah, I think I will just briefly pause here and see if there's any question or see if Olly wants to chime in.
Yeah, no.
Before Olly goes, I actually had one. And I will ask Mike's question, which will come later on, because let's get further into what this actually does, and we'll get to these questions afterwards. But you said the metrics and are all stored. Are these all stored in the customer's AWS account? Can they use it for any other things, for example, besides using Compute Optimizer? In other words, they have a third-party tool which would like to plug into those same metrics. So when you turn it on, does it emit specific metrics for cost optimization, or just turns on all the metrics and we start processing that data and provide those insights?
Yes. So I think there are a couple of metrics CloudWatch will intrinsically they will collect, and those metrics is not regarding to there's no privacy issue for those metrics. We cannot look into what is inside what you are running it. We just need a monitor to make sure that you're actually running your CPU and your memory efficiently, and that's why we collect those data. And for Compute Optimizer, when you enable Compute Optimizer, we will automatically reach out to CloudWatch and get those data. We only store those data for 93 days. And if you don't want us to store those data, you can also cut a ticket and then request us to remove those data from any kind of like training purposes. But basically we are not, we don't have any kind of visibilities on your data, and that data will only be used to generate recommendation.
Okay, cool. Olly, you wanted to add something, and I'm sorry I cut you off.
No. It was a very similar question. Yeah, my question was all around how does the data get in there, and that was covered. It was good. I was kind of curious to know what was being gathered, and if it was just infrastructure, or if it was application, or what's coming.
One thing I would just want to add is like you don't have to enable container inside. I realize that there is an extra cost on the container inside. You don't have to do that. It's totally for free. Yeah.
Nice. Good to know.
Yeah. And I think one thing Maish mentioned is that can you actually import some data from a third party? We actually start doing that. We have cooperated with 4 different monitoring partners, but that function is also being released last year as our reInvent launch. It's called third-party metric ingestion. That's part of a capability only limited to EC2 memories metrics so far, and we will plan to expand it to cover other resource type.
Good to hear. Nice. So how does this actually work? I'm sure you prepared a demo for us to walk us through exactly what this is and what kind of insights. So would you like to share how this actually works and show us, please?
Yeah, sure. So when you start landing the like Compute Optimizer, and this is like the homepage of the Compute Optimizer, and we basically have a look back period of 14 days. So I mentioned you at least need 24 hours of data before you see recommendation. So we will basically collect from 24 up all the way to like 14 days. And 14 days is a cutoff period that we will use a maximum of 14 days worth of data to generate one recommendation per ECS service on Fargate. So I will rewind a little bit and just show you your landing page of like a Compute Optimizer, and we will provide all of your like saving opportunities over here and break it down with a like resource type. And you can also see how many of your resource are actually under like performance risk. The performance risk is basically means you need to upsize your resources. So in this case, we don't have any ECS service on Fargate need to be upsized. And then we have an independent block to show each kind of resource in a very high level way. And you will be able to click in and directly jump into the resource page to see the detail about it. So we see our ECS services on Fargate. There are two services in my accounts currently, and one of them is optimized. The other one is over provisioned. And I want to see why my ECS services on Fargate is over provisioned. This means I'm paying extra money that I shouldn't have. So I want to cost optimize it. So I will go in.
I'm going to stop you one second, Wenyen, because I would just like to welcome all the new attendees which are starting to view the stream, and those are also going to be watching us on the recording as well, either on YouTube or on Twitch. Thank you very much for joining us. We're on Containers on the Couch. We're talking about Fargate, cost optimization, and of course, AWS Compute Optimizer, which helps you achieve that. So please continue.
Sure, no problem. So we are currently in the recommendation page to view all the recommendation we generate for my ECS services on Fargate. So I currently have 2 ECS services on Fargate are eligible for recommendation. So there are a couple restrictions on the recommendation. First, the recommendation has to be a healthy container. It has to be in a steady state. And the second is that it needs at least 24 hours of the utilization data for that particular services. And the third thing is that it cannot have step scaling, or if it have target scaling for CPU, then we will generate only memory recommendation and vice versa. So that will be the major restrictions we currently have, but we can talk a little bit more about it. But besides that, once you got your 24 hours worth of data, we pop out a recommendation for you. Okay, so we are seeing that one of the service is over provision. So basically means that we are paying more than what we should. And if you land on this recommendation page, you will see basic all the information telling you why it's over provision, because both CPU and memory are over provision, and how much saving you can actually have. So you will have an estimated monthly saving. Now I'm paying $14.22 24 cents more every month based on the on-demand price. And my saving opportunities for this particular service is 50%. And of course, because I'm oversized, so I don't have a performance risk. So the performance risk means that you will normally have under provisioned services. And
sorry, just a quick question on that. So is that dollar amount, or is that utilization? Is that because I'm running too many tasks in my service, or is that because my task is too big?
It's because your task is too big. So this is a really good question, because it's actually brings to the concept. So we provide vertical optimization instead of horizontal optimization. So instead of, we think the auto scalings will help you achieve the horizontal optimization. Once you learn about your utilization patterns, you will be able to tell and set the auto scaling policy. And that's some things we don't talk about in here. For here, what we focus is on the vertical scaling. So we're trying to make sure each of your tasks within this service are right size to take on the workload without any kind of performance issue, but also not having too much excess capacities, if you will.
Right. That makes sense. And then that's the I guess the t-shirt sizes that you have with Fargate. And so you're saying is the t-shirt size that you've chosen, you can choose smaller or bigger sizes.
Okay.
Yes, that's correct. And I think one thing about like ECS service on Fargate is that you can think about this is a certain ECS service is certain kind of dish, and then task definition is your recipe. And then so all of the things, all of the task and container being generated is basically the same. So under this services, because it's following the recipes. And that's why everything is controlled by the task definition. And this is actually where we are going to point you to optimize your ECS service on Fargate. Okay, so let's continue on this this table. So we can, it's not too many informations. We provide the necessary information in this overviews sections, and we will tell you why you are oversized. You see your CPU is oversized, your memory is oversized. And here you go. You can see you have 500, I have like 512 CPU. It means like 512 CPU units. It's 0.5 vCPU, by the way. And actually I can cut it down by half, and also the same for my memory. This is, and I want to know more about it. So I can go into this detail page. And when I go into this detail page, I can get more information about the pricing detail, the per hour price details, the price differences, and also the service name and other task definition name here. I can get more details information, but the most critical information here, there are two more important information. Is like one, if you have a container size defined, if you have a hard limit for your container size, then we will also provide you a recommendation to adjust your container size. So if you are shrinking your task CPU size or task memory size, your container can also shrink it proportionately and not having issues when you are relaunching your ECS service Fargate with updated task definition.
And I just kind of wanted to drill in on that a little bit. So there, an ECS task is one or more containers scheduled together, and when you run a workload on Fargate, the mandatory thing you have to pass into us is the task size, and that's what we're seeing here right now. It's a 512 CPU and a 1 gig of memory task. That's what's been given into Fargate, and that's what you've gotten, what you're getting billed for. If you run multiple containers, and so a great example is you have an application container, and then you have some sidecars. You may have like a logging or a monitoring agent or some sort of security agent. And so then you have 2, 3, 4 containers inside of the same task, inside of that same task capacity. And the I guess the middle box on this screen here is where you can actually apply limits to those containers. So the task is a gig of memory, and you want to make sure, without a shadow of a doubt, that your workload has, I don't know, 512 meg of memory or 756. So you're logging your sidecar, your monitoring sidecars, they're still working, but you've reserved the capacity for the container within the task. And that's what this recommendation is also providing you here. It's that container size within the task if you had multiple containers.
Yes, thank you for the details. And also we provide if you have like hard limit for your CPU and memory size for all of your containers, you can have up to 10 containers within a task. and we will basically provide you adjustments, recommendations to make sure you adjust them. Even though we're increasing the task size, we also want to make sure you can increase your container proportionately. So if your workload is predominantly being run by one container, it never goes to an issue if you follow our recommendation and adjust your task. Yeah, and that's the first critical information, is that we think about this. We help you not only right-size your task, but also your container. The second thing is this utilization chart. And these utilization charts will tell you a lot of stories. So basically in the CPU utilization and in the memory utilization. So in this case, the reason why we're oversized is because I barely use my CPU and I barely use my memories. So it's a very low utilization things. And I set it up this way to show you we can help you scale down as much as possible and help you to achieve your savings. So in the CPU utilization, you can find out what your current utilization is. And that would be a blue line. It's like this. What's your blue line? And then we will basically taking your utilization data, and then we will make projections and then think about different kind of possibility, because this is like a serverless service. So we will thinking about different scenarios and different kind of possibilities to help you find out a range, a recommend upper bound and recommend lower bound. So that will be your new utilization range. That's if you follow our recommendation, then your utilization will probably land in between that range.
Nice.
And it's
this
also,
is, I guess this is one of the differences, I suppose, with some of the monitoring tools, right? You can actually see where you would fall if you make the recommendation.
Yeah. And also it's the same for your memory utilization too. And I would like to add a couple more details to explain how we surface this kind of utilization. So we know that the CloudWatch granularities is like 5 minutes, but actually in this ECS service on Fargate, we take in one data point every single minute to increase the granularities of your utilization. And the reason why we have this maximum and average is because we want to make sure we capture all the spikes, because ECS service on Fargate is pretty sensitive to the spikes, especially when you are starting the ECS service task. If your spike is going too high, then there will be a self-protection mechanism kicking in. That's what we want to prevent when you adopt our recommendation. So we basically take in the highest point on every single minute to represent your utilization data. And then we feed that in for the entire past 2 weeks. That will be the data we use to generate the recommendation. And you can also, filter down if your service only has like one of the utilization, one CPU or memory, you can also use those filters. Yes. And these can also be achieved by the APIs. We will share our news blog and also our what's new, and there is a detailed procedure how you can adopt our recommendation through APIs. Before I dive into how to make changes on the test definition, I will stop over here and take in some question.
So you already preempted my question, of course, that it's very nice that we have all this information available in the console, but how can customers use this information programmatically? For example, I'm trying to think of, can customers pipe a recommendation into a CloudWatch alarm or an alert? Is there such a concept of that, or creating those kind of things, for example, that they can run this on a regular basis, that if Compute Optimizer, I started a workload, Computer Optimizer is running in the background, and I don't want to look at the console the whole time, but I want to get an alert to say that it's not optimized correctly, and it will give me the recommendation or whatever else, the information that I need. Is that possible?
So we do support, we do have APIs that you can pull out the results. It's Get ECS Service Recommendations API.
Okay.
We don't have like intrinsic alert built in, but you can definitely build a small program on top of it to periodically take in those recommendations. And one thing we saw like a lot of customers do is like they basically call our API too frequently. You don't have to do that. We are a batch service process. We can only generate recommendation after we accumulate 24 hours of data. So
Okay.
we don't generate it like in a very, very short cadence. So you can only
Okay.
call our API to get your new recommendation every 24 hours. And we have
Okay. So you don't have to run
verified.
it every hour or whatever, because it won't really change. You're only going to make a recommendation once every 24 hours.
Yes. And we also
Okay.
verify our reliability of our recommendations. So there is a certain test. We call it a consistency test. And normally our recommendation is like at like 100%. And what I mean by the consistency test is like if you follow through our recommendation to update your task size to what we recommended you for, and then now there is a new new task being launched, and what will our new recommendation for the new service is normally the same. So when you optimize it will keep optimizing. It's almost all the time. So which means that our recommendation is pretty sound if you have a more predictable workload.
Cool.
Okay. So I will show you how we can change this in the console. So if you need to like update your task definitions, you can use your API. You can use register task definition to update your task definition, and then you can use update service to update your task definition to a newer revision. But from the console side, you can click on the task and then come here, and then you first go to your task definition and find the task definition that is associated with that over-provision task. And you just go in and create a new revision. You can use it to import your JSON files here too. And all you need to do is to reduce your memories and reduce your CPU. So this one is apparently being optimized to the lowest CPU and the lowest memories. And then if you have container, you can also optimize it over here and update it, and then save, create another revision. So now you have like 3 different task definition on this one. And this is the one you follow our recommendation. And this is the one before. So now you have to go to your namespace and then find out your cluster, and find out your services, and then update your services. And you can find this task definition and then update to the latest revision. And then
this will deploy a rolling update to your service so that you, depending on your configuration, that you don't incur any downtime, and will remove the old tasks, etc.
Yes. You will have a minimum downtime if you set your like timeout and your health check correctly. Yeah, it will not have any kind of interruption. Yeah.
Cool.
Yep. So this is basically the user journeys, and I wonder whether Olly have some other takes from the ECS service standpoint. Otherwise, we can take in some questions.
No, it's super interesting. So the idea that I guess Compute Optimizer is providing free recommendations to help reduce costs. It's not a scaling mechanism. It's not there like invasively moving workloads up and down. Like it's instead just providing recommendations, which is actually really useful because you can then plan how you want to handle that upgrade, how you want to roll it out, and how you want to move between revisions. Makes sense.
Okay.
Yeah. So I think in some of those workload, what I want to add is like if you are, for example, actually our Compute Optimizer service is actually built part from ECS service on Fargate. So like this kind of like batch processing workload or CI/CD workload that has regular cadence, regular patterns is very suitable to use Compute Optimizer to help you find the right size of your Fargate task. Even though you have, for example, the web applications, maybe you are building like a shopping website and there is a surge during like Thanksgiving or Christmas time, we will still be able to help you capture the patterns of that particular period. So you can later on, you can think about, how you will be able to size it accordingly at a certain period of time.
I suppose if you think about things we talked about at the beginning, the idea of having to simulate workloads and trying to find production-like environments to simulate workloads on, what you're here, this is in theory providing recommendations on your production workloads in a non-invasive manner. It's kind of, I'm not saying you shouldn't do that. I think you definitely should be trying to right-size your workloads from the get-go, but at the same time, this is constantly providing recommendations in a production environment.
Correct. So you did mention the fact that this, as we say, is a recommendation service. And as we saw in the console itself, there's no way to actually make a change or click a button, change the size of the task automatically. It all has to go through the console, changing a task definition, new revision. So one of the questions we actually got from Mike, who's one of our container heroes, and I'm putting it here up on the screen. I don't know if he's still with us because he said he had to drop quickly, but in any event, the idea would be it's for an improvement and some of the feedbacks that some of our customers, that maybe they do actually want us to automatically optimize for them, which is a very interesting idea. At the moment, of course, the functionality is not there as part of the service, but it could be based on the feedback and, of course, what we hear from our customers and how valuable these things might be, things we might think about in the future. So yes, Mike, thank you very much. At the moment, it's not there, but there could be that we'll think, thank you very much for the feedback. We'll pass it on to the service team so they can learn a little bit more and see how we can perhaps enable our customers to do this in an easy way as well, to remove, as you said, to remove the toil of the undifferentiated work of managing this on their own. So thank you very much. That was one question. The second question is, actually, I had one which hasn't come in, but this is all done for ECS services on Fargate. We don't have the same thing for ECS on EC2. Okay, that's correct. Why not? What is the difference between the two different things? What is makes it so either, I would say, easy or difficult to do it on Fargate that we can't or could do on EC2? Can you explain to me the difference between them?
Yes. So I think I will address the first questions. I think that's a really good questions. Why we don't automate it and why we are not taking up the latency. I think that's actually some things when we are investigating this, we have put a lot of thought about it. So first of all, the challenge would be how on the latency part, like how do we actually measure customers' latency? Because that's actually pretty, we will have to know more information from the customer side, okay. And there will be a lot of back and forth between and finding out what's a common metrics we can take across all the board, which everybody can accept, and they can give it to us. That's some things we need to figure it out. And the second thing is for the automation. Automation is definitely on our horizons. We are thinking about it constantly, but we are thinking about it in a more cooperative ways. So AWS in the future, probably ACO, Compute Optimizer, would be a recommendation service. But if you want to enable your actions, you can probably have a one-click in your ECS console, and you can see it, because we currently Surface actually trying to put out our recommendation to different kind of services. Like EBS is the most easiest one, right? And I think ECS on Fargate can be another one. That is very easily to update. You only have to update your task definitions, and you can have like one click. You can have a view of all your services in your ECS console, And if you want more information, you come to Compute Optimizer. We tell you why we provide the recommendation. Otherwise, if you trust us, you can just execute it on the console. And that's definitely some ideas we are investigating it.
Cool. Thank you very much.
And as for the second question, I would also talk from our side, and I understand the ECS on EC2 is much more challenging. Also want to learn a little bit ideas from Olly on this. So from our side, the ECS services on Fargate is the first step to, basically covers all the services. And we do have some like a resource limitation, so we don't have enough people to support them together. That's one of the reason. And the other reason is that ECS services on EC2, it's much more difficult to size, just like what Olly has mentioned in the beginning of the talk, that it has customer need to size their virtual machine pretty well to fit into like different kind of tasks into one virtual machines, and how we can actually provide the right size, the meaningful recommendation to the customers is another kind of challenge. Yeah, but that's definitely on our horizon, and we do want to cover all the container services in the end.
So I think we're going to start wrapping it up. Is there any final things? I'm going to, of course, there will be in the show notes the links, of course, to both the blog that you wrote, Wenyen, and the What's New post as well, that you can find them. I'll put them back up on the screen over here so you can see them as well. So this is the blog post. And of course, there's the What's New post as well. It's also going to be there. Look at them afterwards for the recording in the show notes. Are there any other things you would like to share before we wrap it up for today?
Yeah, I think you basically ask the future roadmap questions in the end, and that's something I do want to say. And I would love to hear your feedback. You can feel free to reach out to me or the team, and love to hear your feedbacks on using the service. I can provide my email here, so welcome to reach out.
Perfect. Thank you very much. Olly, any last closing notes before we wrap it up for today?
No, nothing. No, I would say just sizing containers is still such a hard challenge, and this recommendation engine that is no cost, no intrusive behavior. It seems a pretty cool idea. Just turn it on, see what happens, see what recommendations you get.
Yeah, I completely agree with you. I mean, there's no actual effort involved, and as you say, there's no cost, so it's a no-brainer pretty much for anybody who's using ECS and Fargate to get the insights.
Right.
I'd like to thank you both, gentlemen, for joining us today. Both, thank you very much, Wenyen, thank you very much, Olly. If you haven't hit the subscribe button on our YouTube channel, please do so you can get notified of our future episodes, which are going to be carrying on throughout the month of July and further down the road. Also, don't forget to subscribe for Twitch, because it's not only our show, there's a number of other shows as well, which are very, very informative, where you can learn a lot of knowledge about AWS and a number of other things as well, regardless of if it's a specific service or how to do things on AWS is also awesome. Highly recommend also subscribing to the Twitch channel. Thank you very, very much, both of you, for joining us today, and we'll see you on the next episode.
Thank you.